You know that feeling, right? You search for something, and what you get back is, well, it's just a list of pages that have your exact words, but they completely miss what you actually meant. Yeah, we've all been there. Today, we're going to talk about the tech that's finally changing all that, moving us away from simple word matching to a world where computers can actually grasp meaning. And we're diving deep into Google's Gemini embeddings. Okay, so let's get right into it. To really get why this is such a huge deal, we got to understand the problem it's solving. For decades, our entire digital world has been built on keywords. But that's a really fragile way to find what you're looking for. And this slide just lays it out perfectly. On the left, you've got your classic keyword search. It's basically a game of matching characters. You search for ways to power a home with the sun, and it's just looking for those exact words. But on the right, you have semantic search. It gets it. It understands you're asking about solar energy or photovoltaics, even if you never type those words. It's the difference between hearing the words and truly understanding the idea. Which, of course, brings us to the million-dollar question. How on earth do you teach a machine, something that only thinks in ones and zeros, to understand something as human and as abstract as meaning? Well, the answer isn't magic. It's actually a really beautiful idea from the world of math.
So, the core concept that makes this whole thing work is something called an embedding. And to get it, you don't need a PhD in math. Nope. We just need to imagine we're taking a walk through a giant supermarket.
So here's the official definition. A text embedding is, at its heart, a translator. It takes text, a word, a sentence, whatever, and it turns it into a long list of numbers, what we call a vector. But here's the key. It's not random. This translation process is designed to place ideas with similar meanings close to each other in this huge multi-dimensional map. It's like giving every single idea its own unique address, a coordinate on a map of meaning. And this supermarket analogy just makes it all click. In a real store, apples and bananas are close to each other, right? Because they're both fruits. They belong in the same conceptual aisle. Well, embeddings do that for ideas. Solar energy and photovoltaics get placed right next to each other in the same aisle of meaning. But solar energy and, say, chocolate cake, those are going to be on opposite sides of the store, maybe even in different zip codes. The distance between them in this number space literally represents how different their meanings are. So now that we kind of get the what, let's talk about the who. We're zooming in on a really state-of-the-art model from Google that has taken this whole concept to an entirely new level. This is Gemini embedding. It's a model that was born from the incredible research over at Google DeepMind, and it's built on the super powerful Gemini family of models. It's been designed from the ground up to create these really rich, nuanced maps of meaning, and not just for English, but for text across more than 100 languages. And look, the numbers really do speak for themselves. Check out that top score. Gemini embedding hits 68.32. Now, to put that into perspective, that is a full 5 points higher than the next best model. In the world of AI benchmarks, a jump that big isn't just a small improvement, it's a massive leap forward. All right, so the model is clearly powerful. But for anyone out there who's actually building stuff with this technology, there is one crucial little detail that can literally make or break your results. It's this one tiny setting that so many people just miss. So let's say you're building a semantic search system. How do you make sure you're getting the absolute best, most accurate matches possible between what your user is asking and all the documents you have in your knowledge base? The secret is this little parameter called task type. It's so important. When you're turning all your documents into embeddings to store them, organizing your supermarket aisles, you have to set the task type to retrieval document. But then, and this is the key, when a user asks a question and you turn their words into an embedding to go find a match, you have to switch it. You have to use retrieval query. It seems like a small thing, but the impact is absolutely huge. But why? Why does this one little setting matter so much? Well, it's because these high-performance models, like Gemini, often use something called a dual encoder architecture. The easiest way to think about it is that the model has two specialized brains. The document brain is trained to be an expert at understanding long, detailed chunks of text. The query brain, on the other hand, is an expert at understanding short, sometimes messy, informal user questions. So by using the right task type, you're just telling the model which brain to use for the job, making sure that both the question and the answer are mapped into that geometric space in the perfect way to find each other. Okay, theory is one thing, benchmarks are cool, but what happens when this stuff actually hits the real world? Let's take a look at what companies are doing with it right now. Let's just start with a number. 81%. What does that even mean? Well, that's the accuracy that Box, the big content management platform, got when they used Gemini to answer questions from really complex documents. They saw a 3.6% jump in recall. That means fewer missed answers and just way more intelligence pulled out of their customers' data. All right, next up, in a field where you absolutely have to be precise. 87%. Yeah, in the super high-stakes world of legal work, precision is everything. The legal tech company Everlaw put Gemini to the test on 1.4 million documents, all packed with dense legal jargon. And Gemini came out on top, hitting 87% accuracy in finding the right information. But it's not just about getting the right answer. How about this for a number? 90.4%. And this one's all about speed. Interaction Code, they're building an AI email assistant, and they saw a mind-blowing 90.4% reduction in the time it takes to process emails. This just shows that the model isn't just smarter, it's also incredibly fast, which is absolutely critical for any kind of real-time app. Okay, so let's zoom out for a second. These numbers are obviously impressive, but they're pointing to a much, much bigger shift in how we're all going to be interacting with AI, like very soon. And this quote right here just nails it. For an AI to be genuinely helpful, it has to have context. It needs to understand your stuff, your documents, your past conversations, your company's private data. And embeddings, they are the fundamental building block that lets an AI find and pull that context into its, working memory. Which really leaves us with one last thought to chew on. We've gone from just matching keywords to understanding the deep meaning inside our documents. This is the foundation for the next wave of AI agents. Agents that can actually reason, find information, and act for us. So the real question isn't just about getting better search results. It's about what becomes possible when our machines finally, truly start to understand us. What will they understand next?